Hello, this is a rabbit hole. This is a project that is off the course for the Orange Pi 5 Plus. I got interested in this. I saw Christopher Barrett on Explaining Computers, one of the YouTube channels, and he had one of these. I think he bought it. And then he went off and used it for a week along with another processor, which I forget at this time, but it's not important. I thought, well, this is interesting. I want to learn something about RISC-V systems on a chip. So I went ahead and purchased this thing. So let me just give you a quick overview. I'm going to try to keep this to 30 minutes. Then I may do a follow-up if there is enough interest. So stay with me all the way through and I'll hopefully pique your interest, just as an observer, if not a participant. So if you look up Lichee Pi 4A, which is the name of the single board computer, we've got the Raspberry Pi, we've got the Orange Pi, and now we have the Lichee. I hope I'm pronouncing that correctly. Lichee Pi. Next thing we need is pecan pie, lemon pie, and apple pie. Though apple pie will probably get you a lawsuit from another company. Who knows? Anyway, this thing was announced in March, and I think they first started production or sales in June. But that's history, and there haven't been that many sold. I think less than 500. Don't know. So if you go and search for Lichee Pi 4A on the internet, you're going to find this wiki Sipeed, that's the manufacturer.com/hardware/en for English, Lichee/TH1520. Now Alibaba makes this system on a chip called the T-Head 1520, which is a RISC-V reduced instruction set computer version 5. The previous versions of RISC were done by a company called MIPS out in California. There was an R3000 and an R4000. I think they were clocked at like 300, 400 megahertz. Used in silicon graphics and other systems. And continue on with the URL, it's lp4a.html. And go down the left-hand side here, you'll find Lichee Pi. There's Lichee Pi 4a, and then there's a Lichee Pi 4a tongue twister. Go down here. And then there's this introduction and this other part. And I think this is the introduction. Let's see. If not, I'll just back up. Yes, it is. Whoops, we're going to go through here and restart the... Yeah, well, no, it's a little bit different. Well, let's go with this. So, here it is. Update history. Okay, that's for the web page. Okay, it's a high performance Linux development board. So now this is a development board, so it's not for everybody. Mostly hackers, experimenters, nerds, people that want to just play with something new and be at the forefront of the technology. So it's based on the TH1520, so it's got 4 cores at 1.85 gigahertz clock. You can clock it up to 2. It's got a neural processing unit for those who want to do AI. It's got a graphics processor. It can hold 16 gigabytes of DDR memory, 128 gigabytes MMC for the operating system, and you just use it as a disk drive. It supports a 4K display, but I'm using a 1080p 43-inch monitor and I'll show you one little difficulty, but it's hopefully be resolved. They can do 4K input camera. It's got two gigabyte Ethernet interfaces. It's got 4 USB 3.0, and then there's a 2.0, which is going to be used for the power. Now this is what the system looks like. Here is the TH1520 processor. Problem: it's thin. It's half as thin as the memory. These two modules here are the memory. There's 8 and 8 if you've got a 16, which I do. And then there's a heatsink that goes on top of this, and because this thing is lower than these two, the bottom of the heatsink is flat, so there's a gap here, which helps run the processor a little warm, I think. But I got an experiment I'm going to do. We'll explain that towards the end. But anyway, so it's the most powerful RISC single board in Q2 of 2023. That may have fallen by the side. They ran a dry stone benchmark, which is a benchmark to determine the number of million instructions per second. And you'll see that the LIP4A, which at the C910 is the processor, quad core, is slightly faster than the Raspberry Pi. And then there's benchmarks. There's a set of benchmarks from EEBC company that does benchmarks, and they ran that, and the Lichee Pi 4A got a number of 7409. And if you use a different version of the system that's compiled with optimized toolchain, you can almost double that number. Then there's another benchmark called Geekbench, and here's the Lichee Pi clocked at 1.85 gigahertz using a single core, and then the results with 4 cores. And you'd think 4 cores would be 4 times as fast, but there's some conflict between cache and memory, and etc. If you overclock it at 2 gigs, which is what, 15%, whatever, no, it's less than 15, somewhere between 7 and 10% overclocking, you get a slight change. And I personally believe that overclocking it and overheating it is not worth it. Here's the Raspberry Pi. And the Raspberry Pi at 1.8 gigs beats the RISC-V processor for this benchmark. Not true for the dry stone. So it's whatever. Look through the discussion here to find out why it's a little bit slower, but that's all right. The Raspberry Pi 4 8 gigabytes is $150, and the 16 gigabyte with 128 gig MMC is about the same price. Okay, now I've been doing the series on the Orange Pi 5 Plus, and it's got 8 processors, 4 of them at 1.8, and then there's 4 at 2.4 for about the same price. So the Orange 5 Plus is, cost per CPU unit is cheaper, but I'm interested in the RISC-V architecture. I'll explain more of that. So that's why I bought this system, and you may be interested in it too. So here's the parameters on, I won't go through here and read all this stuff, but the GPU supports OpenGL and other graphics. The neural processing unit, up to 1 gigahertz, and there's performance here, and it supports all this other stuff. I'm not going to do any AI stuff. The video, you can decode H265, H264, and MPEG-4 of this, so you can play videos, movies, and we'll try that. you can encode RAM. You've got two options, 8 and 16. System I'm running on here is 16 gigabytes. The MMC I'm using 128 gigs. All right, oh, let me go back up here and see. I forgot to show you. Nope, it's not here. Let me go back to this other page. Sorry, this is going to be a little disorganized or a free format, but that's okay. Let's go here. There's an online store, AliExpress, and this is the only place I found you can get this thing. Come up with this page. And shows here that you got a picture here of the Lichee Pi 4A at $3.49, but that's not true. It's this little critter here. It's an RV debugger. The CPUs are here. Let's pick this one. This is the 100. Well, let me go to the cheaper version. Let's see. Is this the cheap one? Nope. This one is. I had a 33% chance of getting it right. This is the cheap one. And it has 8 gigs of RAM, 32 gigabytes of MMC. It's for $135. The next one up is, oh, this is a cheap one. This is a cheap one, but you can't get one because there's 0 left. Look down here. Now, the high-end one, which is the one I bought, if you're going to go first class, it's got 16 gigs of RAM and 128 gigabytes of MMC. They sell you, if you want to buy a supply, there's a 12-volt power adapter. The system runs about 3 watts idle and up to 6 watts when you're running all 4 processors. And the GPU at high speed. There's a case for $10.80. I bought one of these, and you get what you pay for. Okay, enough of that. Let me go back. Wait just a second. Well, where was I? Okay, I went back there. I got more to get back to where I was on the. Oops, I went too far. Well, let's go back to my wiki. Go back to Lichee Pi. Go back to Lichee Pi 4A. And go back to Lichee Pi 4A. And we did the introduction here. And there we are. Shows you a picture, the benchmarks. Parameters, we were going through that, storage MMC, and it does support a flash micro SD card or a TF card. Has 2 gigabyte Ethernet. It has Wi-Fi, which the Orange Pi 5 doesn't have, and it's got Bluetooth. Got 4 USBs, and the 2 is for power supply or flashing the OS. Let me warn you right now, you're going to have to flash the OS. I'll get to that. So there's some hardware information here. The GitHub and the GitHub is a what is it called? It's a dead end. It's not doing anything yet. All right. Here's the guide to unboxing, which if you buy one, you're going to have to do this and just go through it just to look at what's going on. But here it comes in the box. Take it out. There's a system, and under the system there's this package that has the heat sink, a fan, screws for the not screws. What does it have? It has a fan and the heat sink and stuff, Here's the official version. Comes in a box like that. Here's what it looks like when you take the cover off. This piece right here is the antenna for the Wi-Fi. All right, here's the under here, and there's the optional. This is some accessories there, and there's the case. Now, assembling the board, you don't have to do that because the module is already plugged into the connector. Cooler. You want to install the heatsink. There is a thermal pad. It goes like this. Now, I don't know if you can see it here, but these are the two memory modules, and the SoC, the TH1520, is sunken. So if you put a flat heatsink on top of this, there's going to be an air gap there. I'll show you how to fix it. Now, this is the fan that comes with the system. So this is assuming that you're not going to use the case. And I'm trying to remember if this thermal pad came with this, because I'm not sure it did. But anyway, I didn't set this up. Here's where the fan plugs in. The Wi-Fi goes into, it's already plugged in for you. You can do a power over Ethernet using this little module. Here it is, the system. They're all got it hooked together with no case, sitting on a anti-static pad. When you boot it, you're going to bring up Debian, and there are three accounts. One is called Debian. That's user ID 1000. Password is Debian. And then Sipeed, which is the company. Password is Lichee Pi. And that's user ID 1001. And root has no password by default. Now, this may have changed, but I think this is the latest page. First thing you're going to do is change the passwords. Here's the aluminum case installation. All right. You get another fan, heat sink, screws, the end pieces, an antenna, the two aluminum shells, and a heat pad. And I think the heat pad comes with this, but it did not come. That little fan that I showed you previously didn't have a heat pad. So that's why I didn't use it, and I didn't have any thermal tape or paste to work it. So here we go, installing it. Put the heat sink on there, sliding it into the case. All right. Then you have your antenna on this end piece, and it goes here on this edge. This is a 20-pin GPIO, not 40 like the Raspberry Pi and the orange Pi 5 Plus. Get that installed. This is what the end looks like with the two screws. Then the other end has this little piece of foam with sticky on it. You put it on the other end, and this sticks up against the printed circuit board and sets it so it doesn't flop back and forth. Not that it's going to anyway. Then you install the fan. The fan sticks to the case because if you put it on the heat sink, the upper case won't fit. So this is here. This is not, in my opinion, a very good setup, but it works. Now, this is very important here. See here where the fan plugs into these two 2.5 millimeter header. The end connector here is high and will not allow the case cover to go all the way down unless you put it in here on the side first like this. Then when you pull it down, this side pushes that connector in, so that I didn't want to do that, but I did it anyway. it pushes it in. So this will fit just nicely. Then you put the other 4 keys in here. I'm using this with the Cat 6 cable, so I'm not using the wireless. I've got 1 gigabit speed on my Ethernet hardwired, so that's what I use. And this is the final, and there's some other stuff here. And here's an overview of the board. The size, let's see, the size is shown here, 85 millimeters by 103, so it's about the same size. Get it all set up. Now, the image, the Debian distribution, plus the bootloader and everything is available via here Debian. You go out here to the Mega Cloud, and you're going to get a Lichee Pi for a zip file, and the latest version is September the 12th, 2023. So this is 8 days old, and I installed it. Okay. And it fixes 16 gig. I didn't see that in the installed version. I got one, I guess. No, I got it before that date. So evidently there was a problem with using 16 gig. If you're using a small display, you want to use this other image. You can also run OpenWRT, which is a system for developing embedded. The RISC-V architecture is used quite a bit in embedded processing. There's an Android, and then there's some other OSs listed here, and I haven't even tried those. Maybe we'll come back to those. When you download that, you're going to burn it to the Lichee Pi 4a. To do this, you're going to need this burning tool. In order to use this burning tool, you're going to need an AMD 64 or a Intel processor system running either Windows or Linux, and I have Linux. And there's all the steps that you need are down here, and I won't waste your time, but you set the thing is already booted for eMMC. There's a Windows drivers, but it's all in Chinese. Go down here to the Linux, and you're going to download this from the cloud there, and there's a script, or I made a script, I think, but anyway, these are the steps to load it. And when you burn it in, you connect via a USB to C connector to the USB 2.0 port. You're going to burn this. It'll go through here, load the RAM, reboot, go back through here, do it again. Then to go through here and load the root file system, and this takes about 4 minutes. Total time is 281 seconds. Divide that by 60, and I get 4 minutes and a second. So I'm not going to go through all this, but there is a way to set up a dual boot, and I may come back and do that. Get it all installed, hook it up, and power it up, and you're going to come up with a login. You can log in using root or whatever. Open a window so you can do things to connect or update the system, whatever. You can connect to the network, and I did this through a hard cable. Let's go up here and look at. Up here you can see Ethernet network, wired connection, and I can disconnect it, but the Wi-Fi networks are disconnected because, one, I don't have an antenna and I haven't activated them. But if you want to look to see if you can connect, look at available networks. Now I'm running this system on a desktop here, and I'll show you a picture, but I'm running on a desktop without an antenna, and I'm picking up my neighbor's system, and he's got it obviously secure. He's got a password, not going to hack. To connect to a wireless, you go and do, find out what's available and connect. To connect Bluetooth devices, and I have a Bluetooth mouse and I have a Apple Bluetooth keyboard, which I'll probably hook up. Now, somebody can explain to me at some time how you're going to hook up Bluetooth devices without already having a mouse. You're going to need either a wireless mouse using the 4 gigahertz radio frequency, or a hardwired keyboard. I'm using a hardwired keyboard. So you get it all up and running. And that's all time I'm going to spend here. So there I go using so again, didn't I? Sorry. Get rid of all this. You'll notice the most used command that I use is clear. Let me go back to camera, and I took some pictures, and I got some images here. Let's just view them. Now, one utility that I use for looking at images is G-Thumb. G-Thumb, and I installed it. I want to look at everything, and it gives me a warning here, and it doesn't work. Got a segmentation fault. So I will report the problem. Now, the difference between, you may have seen my previous 13 videos on the Orange Pi 5 Plus. Sorry, there's too many systems going on. Orange Pi 5 Plus, you know that one of the things about that system is there are no updates, which bothers me. But I have found with the Lichee Pi 4a that they are updating and keeping the system up to date and solving problems almost daily. I reported a couple of things already, and they fixed them. I'll get to them. So one of the things about Linux, there's more than one way to skin a cat. So there's another viewer called GWEN View, Gwen View. Just go out and Google for viewers, and pop, here it is. Let me start with my setup. Here's the thing from the package. Just like there's the end thing, and I've got a metric ruler here, so that it's about 9 centimeters or 90 millimeters wide. Also, here's the case. It's 2 clamshells or 2 half shells that fit on top of each other. Here's the other end piece, heat sink, thermal pad, fan, screws, and a screwdriver. Here's the fan upside down, and there's sticky tape here to mount it to the top of the case. Oh, note here, it's 5 volts at 0.16 amperes. So that means that the fan takes 0.8 watts. So whenever I'm going to show you the power consumption, that includes the fan. I'm almost 30 minutes up here. I'm going to go more than 30. So here's the box that I got. Okay, looks just like the other stuff. Now, when I put the heat pad here, it's sunken a little bit. I put the thermal heatsink on top of it. Powered it up and it was heating up. Well, no, I didn't power it up yet, but I saw that it was, there was an air gap there, so I removed the heatsink and I cut one section here that's not doing anything and put it here. That gets all three surfaces here, the two memory modules and the TH1520, all touching the heatsink. Then I ran it with a fan on top and it ran fairly cool, I think 40 degrees Celsius. But then I figured out, oh, here, now this is the way the system is running in the case. I did a screenshot here with B-Top, which is the display showing what processors are doing. And you'll see here that the thing is running at 55 degrees Celsius on the centigrade scale. This is in the case with a fan. It's too hot, so I'm going to experiment. That's what I do. That's the reason for the. Now here's a picture of the system I've got. Show you the comparison to a deck of cards. Here's my layout. I'm using the 5-volt supply from the Orange Pi 5 Plus to drive this thing, and here nothing's going on. You'll see that it's 3.99 watts or 4 watts. 0.8 of that is the fan. So now we're down to 3.2. If I unplug the HDMI port, it even goes lower. So part of the consumption goes to supplying power to the HDMI interface for whatever reason. I'll research that. Here's a close-up of the power. This is sorry, I got a better picture here. Well, this is the Orange Pi 5, and this is the Lichee Pi 4A. So you can do a comparison. They're about the same size. It's just that this case is higher because of the fan at the top. And the instant somebody comes out with a new case with this configuration for the Lichee Pi 4A, I will buy it because I want this thing running cooler. I bought, and I just got these today. This is what is today. It's actually September the 19th. I've got my clock up here is on GMT or UTC time. So I'm going to experiment and take some of these heat sinks and put them on the memory and the TH1520 and see if it'll run cooler. Because these things have thermal tape on the bottom of them. And I got these off of eBay. It's 100 of them. And there's a big one just like the one that comes with the system. Here's a better picture of the two systems. There it is with the cards. On all my systems, I use these little USB hubs. 2 reasons. One, it provides its own power, so the power needed to drive whatever you've got attached through the USB port is provided by this power supply, not the one that I'm using to power the system. Also, I'm experimenting, so I plug things in and out, and I don't want to wear out my USB port on my $147 system. This is the mouse. This is the keyboard, hardwired keyboard, and this is a memory card reader, so that I could download these pictures onto the system. I bought the RISC-V book. This is, I guess, is the Bible right now, and I bought it off of a books, I guess, secondhand book. David Patterson and Andrew Waterman are 2 of the 4 founders of the RISC-V architecture. So this ought to be a pretty good book. And by chance, I got this book is autographed by David Patterson. And in the back, there are 3 pages. The blank pages that you typically find at the end of the book is 3 algorithms for doing something, and I'll have to experiment. Don't know why Dave put that in there, but it's in there. So, okay, that's the end of that. So here we are up and running. Oh, I got to do something. Let's see here. What do I want to do? Let me look at my notes. Sorry, I'm going to keep you. I'm going to keep running the class late. That's about it. CD. Oh, I am going to show you one thing. If I do a df minus h, this shows me that the root system, okay, is mounted, and it takes 115 gigabytes. It's 115 gigabytes out of 128 gigabytes of hardware, and the reason for that is that there's 2 partitions. There's also the space for the super block and inodes, information nodes for every file, and so there's some overhead. You don't get the whole thing. Now I just demonstrated something. Let me do this. You see this mouse? If I go and I want to resize this window, this is the terminal. If I go down here, notice that about 10 to 15 pixels above the edge, the mouse can grab it. I'll depress the left-hand button and pull down, and I can resize the window. That is a pain, and I think it's because I'm using 1080p. File a bug report, and on the left-hand side, it's 10 pixels, and I can, this means that when I go to highlight something here, if I don't do it right, if I line up on this, let me start here. Let me start here. If I put the cursor middle of the line, depress the left-hand mouse, and start left, it starts grabbing the bottom line also, and that's because of this offset. So it's a pain. It's a serious pain. So that needs to be fixed. That's one problem. We saw that G-thumb doesn't work, and now there's I have 2 things. Oh, also I installed right now I'm using 4.8 gigs on call it the hard drive, the MMC unit, because I installed a bunch of stuff. It started out at like 3.7, and I installed the network file system. My old buddy Bill Joy from Berkeley days and Sun Microsystems, he did VI, and then somebody came along and did VM, the improved version. And one of the things that Bill also did at Sun Microsystems was the network file system, which allows me to use a file system from another system and mount it locally. And so on my big Intel gaming machine, and its IP address is, there I go with this thing being off. Its local IP address is this. I'm mounting my home directory over there locally at JWST. So if I CD to JWST and do an LS, that's all my files on the other system. And you can see why I take up a whole bunch of space. But I moved something over here. I wanted to do, here's 01. This is a program called RTO1C. Okay. It's having trouble with my simple screen recorder, but anyway, there's a program RTO1.C, which is a physics program thing. Oops, there's my email address, so please no hate mail. Let me clear that. This is a C program I did, and I was working on, and I have a copy of it in backup. The RTO1.c, and there's another version on top of that. There's a program that I love called mgdiff, and I can take what's in my current directory and compare it with what's in the backup directory. And let me blow this up. You can see that I got the programs, the backup RTO1C is on the right hand side, and the RTO1C that I'm looking at here, and I can move up and down, and it shows me any differences, and here is the difference. That this code on the left hand side that's in orange is new. See, I added the ground surface in this planetary atmosphere. Then what did I do here? I changed something. Oh, I extended the size. Oh, this is to add the ground contribution and stuff. This is very useful tool. Well, it was not working a week ago, and I filed a bug report, and they fixed it. So the support is great. Usually you'll do something like diff RTO1.c backup RTO1.c, and you get all this stuff, which is, says this is in the left-hand file, the first argument, and this is stuff that's in file 1 and how it differs from file 2. So it takes a little more. You can see if two files are different by doing a compare. This is a differ byte 7437 in line 184. Good luck with that. Well, watch this. I VIRTO1.c, go 184G, and there's the start of where the differences occur. Neat. What else? There was something else to do, but there's a lot. There's some more interesting. Oh, one more thing. The RTO2.f. That's the first program I ever wrote in my life in 1966, before you were born. I can compile it. It's Fortran. I can compile it using the G Fortran compiler, and it gets nasty. Well, there's a couple of arguments there, and I don't want to have to explain it, but I compiled it to RTO2. To run it, now let's time it. I'm going to run RTO2, and the data set is 001. All right? So it's going to run for 1 minute, no, 1.05 seconds. Took almost 2 seconds before it, got all the printout done and everything. All right, this is the first program I ever wrote in my life. I ran it on an IBM 360 Model 50, which was a complex instruction set computer. It was a mainframe. Its power consumption was 30,000 watts. It required being in a room with a raised floor with forced air conditioning. And if you were in that room, the temperature in the room was about 60 degrees, 65. So operators and people that worked in the machine room wore sweaters and jackets. Okay. The cost of running that system, IBM leased the system to the universities and research facilities and what have you at $113,000 plus per month, which means the data processing center, or if you were cost center based, had to charge for time. In 1976, I was at Texas A&M University, Department of Electrical Engineering, and I'm going to show in another video, another rabbit hole, that the cost of the CPU time in 1976 was $650 an hour. This program, I was a summer intern at Texas Instruments, and they gave me 12 hours of computer time on a Friday night. This program took over 3 hours to complete on an IBM 36050. And that at $650 an hour, you can do the math yourself. How many CPUs can you do? And this is only running on one processor. Sorry, got all choked up. I still am. Pause. Okay, so you can see why I get excited about a $150 computer. Got more compute power in this one single board than we had on the entire planet in 1960. Something for you to think about. And that wasn't that long ago. Let me quit. I'll come back with some more, because there's some more work to do and some more things to show you. Thank you for your time. Hope you enjoyed this. Let me give you my email address, chuck.adams.risc5, RISC-V, one word, no dash, at gmail.com. I set up a special email if you want to communicate with me on this system only. Thank you. Appreciate your time and hope you enjoyed this and learned something.